IDC Media Innovation Lab, a research and prototyping lab focusing on intersection between physical and digital interactive experiences, including human-robot interaction and tangible interfaces for learning. Zuckerman completed his master's degree and PhD at MIT Media Lab and is recognized as the technology pioneer by the World Economic Forum. Iddo Wald leads the development work at IDC's Media Lab and is responsible for hardware material design and prototyping. His research focuses on enhancing natural HCI, human-computer interface, using smart material and biology. Iddo holds a bachelor degree from Tel Aviv University in electrical and electronic engineering and spent 5 years in development team for Intel Core prior to pursuing a double master's MA MSc in Innovation Design Engineering at Royal College of Art, Imperial College, London. And last, Inbal Dutch manages the elderly robot interaction and is responsible for both design and research, currently prototyping a robotic device for healthy older adults. Inbal completed her bachelor degree in psychology at IDC Herzliya. Following her studies and prior to joining the Media Lab, Inbal served as psychology division of the Air Force, in the psychology division of the Air Force, running research in the field of brain-computer interaction using cognitive games, neurofeedback, and EEG in the aim of improving cognitive functions. It's going to be interesting. So, thank you.
Okay. So hi everyone, great to be here. So we're going to try to do a fast-paced introduction to what we do at the lab. So my name is Oren, and you heard the introduction. We're doing a lot of different types of research at the lab at IDC Herzliya here in Israel, and we're going to focus today on social robots and a little about interactive materials. So the lab is a space at the School of Entrepreneurship at IDC. Everybody's welcome to join. And also if people want to mentor and work together with students, we're always accepting new mentors with special expertise. So you're going to see our emails at the end, and feel free to email us. We try to create a space that is both a very creative space for learning, for research, which is a lot of writing and creating publications, and also for prototyping. We have our own workshops for 3D printing, CNC, working with electronics, and also working with synthetic biology and a little more of nanomaterials, trying always to think about what can we prototype, what can we create. And that's one of the things that is very unique about this field, that when we create academic studies, because we control every single part of the development process, we can do very good research, because we can compare between different things that people in industry have much harder time doing because of the time pace of development processes, because of the full control over all of the process. The field that we're at is called HCI, Human-Computer Interaction, what people in industry know as UX. So the academic discipline is called HCI. It's a fascinating field which is interdisciplinary. Its roots are in technology, psychology, and design. So it's all of the fun fields together. And that's why our lab is really interdisciplinary. And as you'll see with the team today, together we represent also these 3 different fields. Today we're going to talk about several topics. I would start with a paradigm shift from humanoid robots to robotic objects. So when you look at industry, not so much automotive or manufacturing industries that we saw today, but more B2C industry and how robots interact with people, not so much in industry but in day-to-day life. What you see that most companies are doing and trying to mimic human behavior, which for them means mimic human appearance, which results in humanoid robots, which might be influenced from movies or might be influenced just from lack of trying to do something else. But we strongly believe that this is the wrong direction. And that trying to create robots that looks like people is going to create a lot of frustration, in a lot of technologies that is dumbing down people. It's going to make people to expect the robots to do something they can't. And we think that the right approach is to think about objects and makes the object smarter. And then the expectation of people is for an object to do maybe a very limited interaction, and then suddenly we're so surprised that the object can do more than we expected, and the interaction becomes much more meaningful and successful. So we're going to talk a little about this today. This is one robot that we've created together with our close collaborator, Dr. Guy Hoffman from Cornell University. This small robot is called Keep. It's very, very small and very, very simple, has only 2 motors, what's called 2 degrees of freedoms, can only rotate left and right or lean forward and backward. And with this little robot, we've already performed a dozen of studies that taught us a lot about how people react to non-verbal communication. So what we see here is non-verbal communication of an object, and people give a lot of social meaning to these movements. We did a lot of studies, both fMRI studies and both self-report human behavior studies. And for example, when the robot leans forward, everybody says it's interested in me, is excited about what I'm doing and about what I'm saying. We also saw in a recent studies that it can influence human-human conversation. So when 2 people interact with each other in a regular conversation, and the robot pays attention to one of them by looking at them, people believe that the conversation was better. Not conversation with the robot, conversation with the other human. So when people talk to each other and there is a robot watching us, we think that it's like another human watching us and we're more attentive and we enjoy the conversation better. So there's a lot of really fascinating research that can be done with these very subtle emotional communications that robots can create. We also have a representative in the audience here today, Shlomi, over there. Shlomi, can you say hi? So Shlomi is from Intuition Robotics, which is a company that a lot of you probably know that took this idea of non-verbal communication to working with the elderly, and they're doing fascinating work on taking this to industry. So this is Keep, and what we're trying to do is to push it further and try to say, okay, what are robots? It's basically motors that moves material, in a very limited mechanical way. As designers and people that like to create expressive things, we're very limited. Motors and mechanics are wonderful and we love it, but it's extremely limiting, and we can't do a lot of expressive movements as much as we would like to. So right now our research also focuses on moving on from expressive objects to expressive materials. What does it mean? What does it mean to take soft material like fabric and suddenly animating it and making it move? How would people react to it? What can we do with it? So that's one study that I want to show. One of the prototypes that we created is called Magnet Form. It's this little table, which I'll show you a movie in a second of how it works. And we're trying to experiment with animating different types of soft materials. Soft materials is fabric, paper, soft plastics. And so we created this little table that you'll see in a second how it works. And it moves these 4 magnets in a way that we can control. So animators or material designers or fashion designer can use this very simple software to animate the movement of the magnets, and then they're free to express themselves with any materials they want. You can see what industrial designers done with it, with a few studies that we done with them to see how they would use this material, can move simple objects in different ways, and can also start to experiment with soft materials, fabrics, and paper. And we believe that the type of movement that is created is something that can be very expressive and can become an interactive material for industry that can allow you to create robots that express themselves in much richer ways than just simple robotic movement. So this is, for example, paper. Paper can be very expressive. We know from a cultural perspective that Japanese have been used paper for many centuries to try and express different movements. We believe that people with the right design talent can start to define a new design language here and try to think how the way that they fold the paper results in different types of movements that can later on can be translated to happy, sad, excited, or angry, in the way that we do it today with social robots. And it was very important for us to create the technology in a way that the form factor is very friendly and simple, so designers can use it in their own studios. So here you can see a fashion designer and mixed material designer using it to really express the field that she's at right now. And she works with material, these types of materials all the time, but she never sees a movement of the material until the end, until she launched the product, if it's a dress or a costume or a design that she's doing for theater or performance. And in this case, it's like a simulation for her that can suddenly create a lot of spark of new ideas. Here you can see us using the material properties themselves to try and create a very different movement. And when we work with designers, we see that they also think in a very systematic way, just like engineers. They're trying to think about what is the properties that I'm working with and how can I develop a type of movement dictionary, which is this, what she was working on right now. Trying to see how the very fine details of each material results in different types of expressive movement. The way that we build this system is very, very simple. It's just 4 servo motors, each one controlling this arm, and each arm has a magnet connected to it, and we created this custom software that allows the designer to animate or to sequence each of these motors, and together we get this result. So in general, we believe that we're right now at this very exciting era, that robots are starting to be used also for social interaction and not only for supply chain or machine or supply chain control. There's a lot of challenges in this social human-robot interaction and trying to understand what people infer from robot movement and how this interaction can be more meaningful. And we believe that the research on new types of materials can be very effective for industry to try and create the next generation of these robots. So with this, I want to invite Iddo, which will explain a little more about the details of how we do all of this motion design.
Hey. Oren talked about how we're doing all this nonverbal communication with these objects, and so movement is obviously a very important thing. And I wanted to talk a bit about, through this kind of case study, about how we study communication with movement. So this is Jimmy. Jimmy is short for greeting machine. It's a robotic object that is we used for investigating how we communicate, do a human-robot interaction in this specific encounter of greeting. So in the meeting encounter. Oh, I know. So this function of it is basically a ball that moves over another ball. So the small ball kind of can move freely over the first ball. Shlomi was here in the. We mentioned before, also took part in the beginning of this development of this thing, and Andre here is a product designer. Is responsible for the later stages of it. What we made this object for is really for researching movement. So we tried to make it as abstract as possible, using very, very clean and simple lines. It's just basically 2 balls. It's very hard to put any association on it. We tested it. People can sometimes see it as 2 different creatures. Some people, it's like the small ball is a face, and so on. Now this is kind of the stages of how we made it. So of course we moved from putting the motors one over the other with the electronics and to a more complex design. So we started with the electronics outside, integrated inside, made it smaller, changed the materials. You can see on the right we moved to a more robust design. We found it really hard, a lot of forces actually moving between the 2 magnets there. So there's the kind of robotic arm that moves with a magnet on it, moves the ball outside. So we moved into this for this design with a slip ring in the middle and these 2 what do you call it? Parts that hold one against the other. But already in the very early designs, around the second one, we started getting into movement, and we started by making a very, very elaborate prototype. That's basically the dome with a stick stuck inside the ball. And we made this like a silly thing to start looking at motion. So as we said before about we went to look at materials, so we went and talked with experts and let them play with the materials and made platforms for them to do it. We have the same philosophy here. We are not experts in movement, or at least weren't at the time. We're becoming more and more now. So we made a forum where we sat down with a choreographer, a puppeteer, an animator, graphic designer also does some animation, and we sat together with this object and a stick and we let them play with it and animate their and make their own movements and see and talk about how would can this thing express happiness? How can it be sad? How can it be bored? What kind of character can it have? Can we give it different personalities? So that was kind of an exploration process to start inform us of how we can create meaningful interactions with this thing. And then we used that information to inform us in a later stage of design. So this is a tool. It's not exactly a tool. This is we made it. One of the main competencies of the lab, I'd say, is this tool that we made for animating robots. So usually movement of robots is designed by programmers, and we want to give people that know how to do it the tools to do it. So this is Blender. It's an open source animation software, and we made an add-on for it, basically to take the animation files from it to animate our own robots. So if I'm just gonna jump here. So this is Blender, and you can see the different X's. What we basically realized is that if we take each of these bones and only limit it to move in like one X, then they're the same as a motor. This is work that we made. We've done originally with Professor Guy Hoffman, who was director of the lab. He's now at Cornell, though we're still collaborating together. If you don't know his work, you should definitely check out his TED Talk. It's very inspirational and everything to do with robotics. This basically gives us the, we basically take the frames from this and play it on the robot, same as you would on a movie. Of course, a bit more complicated than that, because it's not just like you can't make freeze frames on a robot, and you need to figure out some physics and play around with how you do the commands for the motors. But that's basically the idea. And so after we made these things, we played them on our robots. And then, as I said, we talked about interactions. So we went out and made some experiments with people coming into the room and meeting this robot. We designed different kinds of gestures. Main ones are kind of an approach gesture and an avoid gesture. And we made different variations of them. So this is one interesting variation, I think, of a kind of linear, direct motion, more of a programmed motion, comparing to an animated one. Kind of starts and finishes in the same place, but the other one was designed by an animator. And I'll just say in a few words what we learned from this study. We found that with this really, really abstract object, we can create what we define as kind of meaningful social interaction. So people perceive the interaction with the robot as a social interaction. And they also, as you saw here, they can give the different kind of gestures, different meanings. So if you kind of move from, we're trying to really look into the fine details of if you move the effects of the movement from left to right, or from the bottom to the top, and what has more significance. So I can see some of the meaning that people gave to like an approach gesture or to an avoid gesture. Even this, the avoid and approach gestures, the names we brought from the questionnaires. These are not things that we came up with. So that's like from the interpretation that people gave. A few more. So yeah, this is one of the things we do in the lab. So studying that interaction really in detail. Both in like open interviews and also questionnaires, and like that we developed ourselves or like that were developed before. Two interesting insights, I think, from this study. I think regarding so we saw the strength of gestures like this, but about the kind of animation versus linear, we found that the animated version kind of enhances the effect of the results that we found. So yeah, it kind of makes it enhanced. And another interesting thing, specifically about these like non-anthropomorphic abstract objects, is that we found that though people give it intent and they understand it in a social context, they do realize they don't give it a kind of human association. So there's something that I find is a bit more kind of honest about it. It's not tied to pretend to be human. People don't perceive it as human, while they do perceive it within a social context. So yeah, I think that's pretty much it about that. And I'm going to let Inbal tell you a bit more about why we make these robots, I suppose.
Any questions for Iddo before we go on?
We'll take questions at the end for.
Okay, cool. Hi, Inbal. I'm the female representative tonight, I see. Woo! Thank you. Shout out to the women. So I'm going to be a little bit different from the other talks that you listened to, so bear with me. I'm going to talk about people. So, good news, the world is getting old. Specifically today, the percentage of people who are over the age of 60 is about 12% of the world population. And by about 2050, they estimate that that number will become about 22%, which means that we're getting old. Not only are there more old people in the world, but we're also living longer, which means that what we call a Gila Shlishi, right, the third chapter of our lives, is actually becoming something around a third of our lives. So because of this, everyone is kind of stressing out a little bit, and now there's a really popular trend of figuring out how we can promote successful aging. And one of those trends is robots. And specifically, I mean, I don't have to tell you guys that robots are becoming a very, very popular field. And there's already a huge growing rate of robots specifically for older adults. I'm sure most of you here know LEQ, which is Intuition Robotics, an Israeli company. And in the lab, I joined a team about elderly robot interaction, and we decided we wanted to build some sort of robot to help improve loneliness for older adults. And the first thing we noticed is that there's basically no research on what older adults actually want from their robots. So that's what we decided to do. We had two research questions. The first is, what are the needs and preferences of older adults towards robots in terms of their function, their look, and their behavior? And the second one was, what are the main properties that need to be considered when developing robots for older adults? Things that are pretty basic and probably should have been studied before. So obviously the best way to do this is to go and ask older adults what they really want. And that's exactly what we did. We went out and we interviewed 30 healthy older adults between the ages of 67 and 90. And obviously we can't bring them a bunch of robots because that would be very difficult, and they're also very scared of them. So what we decided to do instead is we showed them 6 videos of robots that either already are out in the market or going to be out in the market soon. So they're all commercial robots. And we asked them what they thought. And from there we analyzed what they said, and we found a bunch of quotes about things that they said, and we took those quotes and we organized them in a really nice fashion, and this is what I'm going to show you today. So the first theme that showed up in the quotes that people were talking about was about the robots, and just like we assumed from the 3 things we went to go look at, it divided into the behavior of the robot, the appearance of the robot, and the function. And what was great is that the older adults were really accepting of the idea of robots, even though they didn't really know anything about them. They were really open to the idea of bringing them into their lives, but they had a lot to say about what they wanted. So some things were very clear. They were very, very adamant about the fact that they definitely wanted a robot to have a purpose. You can see in the dark gray, that means that 100% of people said that they want their robot to have some sort of purpose. I'll get more into that in a little bit, but purpose means it needs to do something that they find useful. And also size was very clear. They really wanted a robot that was smaller, which also makes a lot of sense since they're integrating these robots into their daily lives, and a lot of them don't have a lot of space or money. But everything else was kind of a mix that was, as we say in Hebrew, a balagan. They didn't really know what to say. Some wanted proactive, some didn't. Some wanted them to move, some of them didn't. Some of them wanted to talk, some of them didn't. And it was just kind of not clear what they wanted, which brings me to some quotes. For instance, in mobility, one person said, "I'd rather it be stationary. When I felt that I would no longer be in control of what I was doing, I would retire to an old people's home." So they were taking this very, very seriously in terms of yes mobility, no mobility. People were very strong in their opinions. And another example for speech, maybe if it didn't talk, it might be a bit more acceptable. When it's talking, it's intrusive, which we found very, very surprising. I even see some faces here, people are like, what? because I think speech is a huge topic in the field right now, and everyone's trying to integrate speech. If anyone saw Google's new assistive AI, it's something that people are really running forward, and also a lot of older adults talk about how they're very lonely and all they want is someone to talk to, and yet they're like, hey, I don't want to talk to a robot. So we kind of took a step back and we said, okay, what can we do about this